Okay, so we're going to do the nucleophilic addition mechanism that is involved in the reduction of citral. This is the reaction that we did this week. So we've got citral, which is an aldehyde. It's got a carbonyl on the end. It's got a hydrogen here, carbon, double bonded to an oxygen. Okay, remember that oxygen is more electronegative than the carbon. So it's pulling the electrons in this double bond closer to it, giving it a partial negative charge, while the carbon is left with a partial positive charge. So we've got sodium borohydride as our other reactant, a reducing agent. So borohydride is a boron with 4 hydrogens bonded to it, and it's got a -1 formal charge. So this carbon is partially positive. It's electrophilic. Electrons are going to attack it, and it's going to be the electrons right there from this hydrogen bonded to the boron. These electrons attack that, and they drag the hydrogen right along with them, and it gives us this product, this transition, this intermediate. These electrons are kicked off onto the oxygen because carbon can only have 4 bonds at a time. So those are kicked off onto the oxygen, giving it 3 lone pairs and a negative charge. We've got a new hydrogen and the old hydrogen that was on there. So this is an alkoxide. And its next thing is it's going to get protonated. So we're going to have proton source, and that just happens to probably be the water in our guanidinium chloride solution. It's dissolved in water, so we've got water present. These electrons are going to grab a proton and give us the final product, which is the geraniol. Remember, this hydrogen was added. This hydrogen was there to start with. So this is a new hydrogen, and this is a new hydrogen. Hydride, hydrogen with electron pair is hydride. That added in the first step, and a proton with no electrons added in the second step. So you've added a hydride and a proton in this reaction. Okay, so what was the purpose of the guanidinium chloride? The guanidinium chloride lowers the activation energy of the reaction. It's a catalyst, and it's an organocatalyst. It doesn't involve metals, organometallic things that are usually more toxic, less green than this guanidinium chloride. And what it does is the hydrogens on the nitrogen and the oxygen on the aldehyde form a hydrogen bond. And what this does is it stabilizes that resonance structure where there's a negative charge on the oxygen and a positive charge on the carbonyl. So what it does is it stabilizes this situation and makes this more partially positive so that the hydride ion will attack more easily. Okay, thank you.